Have you ever wondered how small the universe really gets? We already know about atoms and the particles inside them like protons, neutrons, and even smaller quarks, but scientists believe there might be something even smaller, hiding deep within the fabric of space and time itself. This is the world of Yak Technology based on the Yoctometer scale. That is, one yoctometer equals 10 to the minus 24. That's a trillion times smaller than a proton. At this scale, we are no longer dealing with particles, but something much stranger, the structure of space-time itself. So what exactly is space-time and how could we engineer it? In everyday life, we think of space as empty and time as just something that passes. But physics tells us these are not passive backgrounds. They're active, flexible things. Gravity, for example, is caused by curves in space-time. And deep down, at scales smaller than anything we've ever measured, space and time might not be smooth at all. They might be made of tiny units or loops, like a woven fabric. What if we could edit those threads? That's what Yoctotechnology is about. You might ask, what could we even build at such a tiny scale? Surprisingly, scientists believe that everything, matter, energy, even the laws of physics, might emerge from these deeper layers. If true, Yoctotechnology could let us reprogram reality itself. For example, instead of making a new material, we could change how mass works in a small area. Imagine creating a tiny bubble where gravity is stronger or where particles have no mass. Maybe even a place where time runs slower or fast. It's like changing the settings of the universe, not just using its parts. So let's take a fun example. In science fiction, people often dream of time travel or warp drives. While those ideas seem impossible, some real physics theories like the Alcubierre drive suggest you could bend space to move faster than light if you had the right kind of energy and control over space-time. Yoctotechnology, in theory, might one day allow this by letting us sculpt space-time itself instead of just traveling through it. We're talking about engineering shortcuts through space, or even building stable wormholes. But wait, how is this different from things like nanotechnology or quantum computing? Nanotechnology works with atoms. Quantum computing works with individual particles and their strange behaviors. But Yoctotechnology would go deeper than particles, reaching the level where space, time, and physics themselves are made. Think of it like this: if chemistry is building with Lego bricks, and nanotech is rearranging those bricks, then Yoctotechnology is editing the factory blueprint that makes the Lego bricks in the first place. Another strange but exciting idea is that information might be more fundamental than matter. That means instead of thinking of particles as things, we might think of them as data, like code in a computer. This idea is supported by theories like the holographic principle, which suggests the entire 3D universe might be a kind of projection from a 2D surface. So, what if we could edit that code? Yoctotechnology would let us change the software of reality, creating particles, altering forces, even changing what kinds of things can exist. Could we really build such technology? Not anytime soon. We don't have the tools, energy, or understanding to reach the Yocto scale yet. The most powerful machine on Earth, the Large Hadron Collider, LHC, can smash particles at nearly the speed of light, but it's still millions of times too weak to probe anything close to 1024 meters. And we still don't have a complete theory that combines gravity with quantum physics, something called quantum gravity. That would be the first step before even dreaming about real Yoctotechnology. Still, the future may surprise us. Just a century ago, we didn't know atoms had smaller parts. 50 years ago, nobody imagined we could edit DNA. Maybe one day, with enough breakthroughs, we will learn to control the very structure of space and time. Yoctotechnology might allow us to build pocket universes, design new laws of physics, or rewind cosmic events by accessing the informational core of reality. In the end, Yoctotechnology is not just science. It's a question about what reality is made of. Is space just an empty stage or a flexible network of data? Is time a one-way street or something we can edit? Could we one day not only explore the universe but rewrite it? These are the questions that Yoctotechnology dares to ask. Yak technology refers to the hypothetical manipulation of structures at or near 1024 meters, a realm where conventional spacetime concepts may no longer apply. This scale is smaller than quarks, gluons, and preons, approaching the quantum gravity domain near the Planck length. At this level, classical notions of size and location may dissolve due to quantum fluctuations in spacetime geometry. Particles and fields may not be fundamental, but rather emergent from deeper informational or topological processes. Yoctotechnology aims to engineer not matter or forces, but reality's underlying architecture. At this scale, an engineered region of spacetime might be able to behave like a new kind of physical law sandbox, like altering not just chess pieces or the board, but the rules of chess itself. Technology relies on theoretical frameworks that extend or replace the standard model and general relativity, such as string theory, loop quantum gravity, or causal set theory. These models suggest that space and time may be quantized and that geometry itself is constructed from discrete entities or information units. Some approaches propose that matter arises from topological vibrations of extended objects like strings or branes. Others argue that the universe is a computational network of events where causality and entropy emerge from deep quantum structure. At this depth, the fabric of existence is computational and relational, not geometric in the classical sense. In loop quantum gravity, space-time is made of discrete loops. Yoctotech would allow editing those loops directly, like not drawing a map, but rewriting the underlying code that tells space how to be a map. In Yoctotechnology, space-time is no longer a passive background, but a dynamic, editable medium that responds to quantum information changes. One could theoretically modify local curvature, connectivity, or even dimensionality at sub-Planck intervals. Quantum foam fluctuations, once considered noise, become a programmable canvas for shaping geometry and causality. Altering these properties could produce effects like non-standard gravity, localized time dilation, or variable constants of nature. Spacetime would behave like a field redress-proof substrate, programmable in both structure and logic. A Yak device could flatten or warp a region of spacetime to produce an artificial gravity gradient, like turning spacetime into a flexible fabric you can fold, stitch, or stretch at will. Emerging physics suggests that information is more fundamental than particles or fields, aligning with principles from black hole entropy, holography, and quantum information theory. In this view, matter is a derivative effect of entangled data structures evolving over quantum space-time. Yak technology would target these deep informational seeds, modifying them before particles or interactions manifest. This allows for the creation of designer physical states, particle classes, or even dimensional frameworks from pure logic. The goal is to program the evolution of existence, not just manipulate its outputs. Rewriting the entanglement map behind a region could cause different particles to emerge from the same vacuum, like editing a script so that an actor becomes a different character without changing their costume. Time at the Yocto scale is not necessarily linear or absolute. It is emergent from event sequencing and causal structure. Yoctotechnology may allow reordering events, introducing retrocausality, or creating custom temporal geometries. Causality could become a programmable constraint rather than a fixed principle, opening the possibility of constructing new timeline logics. These alterations could enable asynchronous evolution, time loops, or reverse information flows. Temporal dimensions themselves might become navigable and editable frameworks. A Yocto scale edit might allow a cause to be created by its future consequence in a localized loop, like writing a book where the ending causes the beginning. Yak technology could usher in Planck Scale computing, where logic is executed through manipulation of topological or causal field structures rather than particles or gates. Each bit of information could be encoded in vacuum topology, spin networks, or loop configurations. These systems would compute at 1043 operations per second, using entanglement and non-locality as core features. Unlike quantum computers, these would not simulate physics, they would instantiate new physical systems. They are not tools for computation, but engines of universe creation. A Yocto computer might answer a problem by spawning a consistent universe in which the answer is embedded, like answering a question by building a new reality where the answer exists by definition. Yak Technology's ultimate applications include engineering entire cosmologies, modulating fundamental constants, and creating universe-like constructs. One could generate pocket universes with different expansion rates, alter the arrow of time, or deactivate entire classes of particles. Laws of physics would become environmental parameters, configurable like software. It could also reverse entropy locally or stabilize otherwise unstable vacuum conditions. Such power could transform not just environments, but the architecture of reality itself. A controlled cosmological region might operate with a different speed of light and quantum structure, like opening a menu to choose the rules of the universe before pressing start. Operating at the Yocto scale brings profound dangers, including vacuum decay, where modifying the vacuum structure could collapse our universe into a lower energy state. Other risks include timeline contradictions, dimensional instabilities, and loss of causal coherence in observer-police systems. Because space, time, and energy are interconnected at this scale, errors might propagate as reality failures, not just device malfunction. Ethical and philosophical safeguards become essential, as misuse could reshape the conditions of existence itself. Yoctotechnology demands governance beyond physics, a code of creation. Creating a localized false vacuum bubble might accidentally trigger a chain reaction, consuming space around it, like pulling one thread and unraveling the entire fabric of reality. Yoctotechnology represents not just the limit of technology, but the transition from physics to meta-reality design. It implies the ability to engineer ontological systems, creating new logical universes, and rewriting the principles that govern energy, matter, and time. At this depth, existence becomes software, consciousness may act as compiler, and the universe becomes self-editable code. It completes the arc from manipulating objects to designing existence. If ever realized, Yak technology would mean that humanity ceases to be a product of the universe and becomes its author. Instead of asking how the universe began, we would write the conditions under which beginnings are defined, like leaving the game board entirely to become the designer of all possible games.